Okay, we're going to talk about normal distribution. So in this assignment, standard level, chapter 7, section M, when we're dealing with normal distribution, basically it's when our bell curve is symmetrical from our, like binomial distribution, it has a curve, but the bell curve is symmetrical. Okay, so the symmetrical curve, the general shape looks something like this, where the center of the curve is at the mean. Okay, this is our mean. All right, and that's the general shape of our curve. So the location of the curve and the standard deviation is the only thing that changes the shape. So if the mean changes, then it goes left or right depending on what the mean is, and the standard deviation, if that changes how narrow and high it goes or how spread it out it goes, and I'll show you an example of that in a minute. So whenever we're doing normal distribution, you will see this notation where capital X, which is our random sample, and N stands for normal distribution, mean, and standard deviation. Okay, why is it standard deviation squared? So remember that variance is equal to the standard deviation squared. Okay, so the important thing to know is that all this area underneath the curve is always going to add up to 1. Now, why is that? It's because when all the probabilities of everything, all the probabilities always add up to 1. So if the standard deviation is really small, like right here, it's got a small standard deviation, the height here is going to be high because the curve is kind of squished in. Whereas if we spread it out, like here, if we spread it out, then the curve won't be quite so high because this area here should be the same as this area here. So the larger the spread, the shorter the peak. The smaller the standard deviation, the taller the peak. Okay? You might want to hit pause and copy this down. Okay. Now, this is an important detail here. I'm going to zoom in a little bit. You can print this out in the notes attachment if you want to, or you can just simply copy it down. So from my normal distribution curve, like I said, this is the general shape. If I go 1 standard deviation to the left from the mean, that is always by definition 34.13%. Okay, and if I go 1 standard deviation to the left of the mean, then it's also 34.13%. That tells us where the standard deviation is going to be. If from here to here, this is 34% of the space under the curve. Remember, normal distribution curves are always symmetrical. Now, 2 standard deviations away from the mean, the area between here and here is 13.59%. Okay, and the area 3 standard deviations away from here to here is 2.15%, and then above that is 0.13%. There's almost no area on the ends, which you would expect that that's what it would be. Okay, so I'm going to show my handout. If you choose to print it out, great, you should at least look at it. So let's look at the example that's here. A couple examples here. So this one has a standard deviation of 5. I'm sorry, this has the mean of 5. So A and B are going to be, the mean is going to be here at a lower value, versus these have a mean at a higher value. So this having the mean of a higher value is going to make it move to the right. Okay. Now notice here we've got, this has a very small standard deviation, so because it's very small, the peak is going to be higher, okay, and it's more squished in. Whereas this one here has a much a bigger standard deviation, so the spread is going to be greater, and it doesn't go as high. Okay, and let's look at one more. This one has a standard deviation of 3, so that's even bigger, so the spread is even going to be bigger. Okay, and then the mean was right there. So you may want to print this. I think it's a really good resource. And here, so they said the mean is at 4, so that means right here they write the number 4. And if my standard deviation is 3, then that means here, if I've gone 1 standard deviation to the right, that's going to be at 7. I'm going to add 3 to get 2 standard deviations. I'm going to add 3 to get 3 standard deviations. And then here I subtract 3, subtract 3, subtract 3 to get 3 standard deviations in the negative direction. Okay. So here's this curve which I just mentioned to you. I hope you print this out. Now let's do this one example together. Okay. A sample of can of peaches was taken from the warehouse. The contents of each can was weighed. The mean of the can was 486 grams with a standard deviation of 6. So if the mean was 486, that's what we write here is 486. Okay? So this value right here is 486. And the standard deviation is 6. So here, notice that this is 480, and then we subtract 6 from that, 476, and then 468, right? Okay, now state the proportion of the can that weighs between 480 and 486. Well, between 480 and 486 is this value right here. And what we said earlier, if I'm between the mean and 1 standard deviation away, this is going to be 34.3%. So the answer for this is about 34.13% between 280 and 286, because this is the mean and this is 1 standard deviation to the left. Let's look at the next question. More than 492. So 492 is right here, and more than 492, I'm going to have this space here, and this space right here, and the little teeny tiny space here, right? Because as we mentioned here, the area of this space is 13.59%. The area of this is 12.15. The area of this is 0.13. So in order to figure out the area greater than 492, like it says, more than 492, I'm going to take these 3 areas and add them together. And so this one plus this one and plus the last one, my answer is going to be 15.887 cans are expected to weigh more than 492. So that should help you with tonight's homework, and send me an email if you have questions.